Okay, let's go ahead and take a look at average and a percent error. So when we think about lab data, we have to think about how well we did and kind of what the numbers are telling us. So a lot of times we'll use these two things in chemistry to do that. So for an average, rather than measuring once, it's a common practice to take the number of separate measurement units. So you're not just going to measure something one time in a lab, right? You're going to take multiple trials, usually in science. So this eliminates any outliers. So if you did it once, you would maybe have an outlier in your data, and if you don't repeat it, you're not going to know that. So basically, an outlier is a result that doesn't fit the expected outcome and allows for an average to be taken. So we do have to calculate averages. So, for example, a student weighs a golf ball on 5 separate occasions, and the results are listed here. So if I want to get the average mass, I just have to add up all of the things and then divide by the number of things. So here's the work for that. So I'm going to add up all my numbers. There are 4 total numbers um, here, and then I'm going to get my final answer. So this is the average of a golf ball and the weight of that in grams. Now, the other thing we use is percent error. So a lot of times in chemistry, we justify things or try to figure out what's going on by figuring out basically how good we did. So in certain situations in a lab, you might be measuring a quantity that has an accepted value. So you have something to compare back to. So it's like, this is what is thought to be true. The difference between the measured result and the accepted result is the error. So basically, you're trying to get to the accepted value, but of course, not everything goes right in the lab. So to calculate that, what we want to do is this formula. So let's look at it with numbers. The accepted value for the mass of a new golf ball is 45.93 grams. A student weighs a golf ball and finds it to be 46.45. So first, we want to take the difference of what we measured, which is the 46.45, and we want to subtract the 45.93. That is the accepted result. Then we're going to divide by that accepted result. So I can see how far off I was percentage-wise when I think back to what I should have gotten, the accepted result. And then to switch it to a percent, you can just multiply by 100. The biggest thing here to remember is to do the subtraction first, press enter on your calculator, then divide, then multiply by 100 to switch it into a percent. So it's kind of like 3 different steps here, but you just have to decide what is accepted versus what you got. So measured value is always what you did and what you got from the lab.